Hello children, I Ruby Sharma welcome you to the next maths class. Today we'll be solving LCM problem sums. So I hope you have understood HCF, HCF problems, how to find the LCM by both the methods. So let's do the HCF problem, LCM problem sums from your textbook. This is one of the sums, question 2. The question 2 is that three boys step off together from the same spot and then their steps measure one of the child's step measures 63 centimeter, another one 70, and another person's steps per step 77 centimeter. Now they are asking you to find out the minimum distance each person should cover so that all can cover the distance in complete steps. Now to understand this question, I've just given you a simple example. Now see this. Here, these are the, suppose two persons who are moving in different steps. The steps measure differently. Now you have to find out at what point of time their steps will measure equal distance. Now suppose these are three children. This say 1 centimeter, baby steps. He takes only 1 centimeter at a time. His steps measure, one step measures 1 centimeter. So he will be going one step at a time. 1, 2, 3, 4. The second person, child's steps measure 2 centimeter. So he'll be going 2 centimeter. Then he'll be going next 2 centimeters. So first step he'll be at 2 centimeter. Next step the person will be at 4 centimeter. Next at 6, next at 8, and so on. And the third person, his steps, one step measure 3 centimeter. The next step is 3 centimeter. Then again 3 centimeter, he'll be here. So they are moving in, the steps are different. The measure of each person's steps is different. Now you have to find out the minimum distance each one should cover. What is the minimum distance each one should cover so that all can cover the distance in complete steps. That means complete at the same point, they will be together. Together in the sense the steps, they will be crossing complete steps. Now see, at this point, he will cross the 2 centimeter. He will also cross 2 centimeter, the first step only. But he will not be stepping in that 2 centimeter. So they will not be in that same complete steps here. So what is the minimum distance in which they will be completing also? Each one, and that number is common to each one. So what are you observing? This will come here at one point of time. He will be crossing 6 centimeter at one point of time. He will be also crossing 6 centimeter. He will also be stepping on this 6 centimeter, isn't it? So what is 6 actually? It is the multiple of this 1 also, 2 also, 3 also. There are many multiples for 1, for 2, for 3, but the common multiple for 3 of them is 6. So in the 6 centimeter, they will be covering complete steps. Next, they will be covering at 12 centimeter. So are you observing if three persons move together when they will be completing the same step? Cover the distance in complete steps. So in this manner, this shows what? And the minimum distance will be the minimum common multiple. That is the LCM. So you write the statement in this manner, and then how to find the LCM? By prime factorization. Just a revision recap. Now 63, it will not go by 2, isn't it? The first prime factor. The next is 3. 3 2s are 6, no remainder, so 3 1s are 3. Then 21 will not go by 2, but it will go by 3, so 3 7s are. 7 will not go by 2, neither by 3 nor by 5, all the prime factors. So next prime factor 7 will go is 7. 7 1 is 7. So in this manner, I find all the prime factors of each of the numbers and I've arranged it as a product of prime factors. That is prime factorization is what? A number expressed as a product of prime factors. So this is 3 into 3 into 7, and it is correct also, isn't it? 3 3s are 9, 9 7s are 63. So it is, this is prime factorization of 63. So the 3 prime factorization I've done and written it. Now, how do you find the LCM? LCM is what? You have to first note down all the prime factors involved here, 2, 3, 5, 7, 11. So I've noted down. I've kept a track of all the prime factors, and then you will highlight or color or circle the maximum times they appear, but only once. That means 2 is appearing here, so I have highlighted this. 3 is appearing here, maximum number of times, 2 times, so 3. Now 5 is here, so I have highlighted 5. Now 7 is here also, here also, here also. So only once in this case, okay? So anyway, you highlight only once. And then 11 is only here, so I'll highlight that. So all the prime factors must be highlighted, but with the condition, you have to see in which line they are the maximum. Okay, maximum number of times they appear. Now here, what is the LCM? The product of all these highlighted terms here. And then how do you multiply also? I've just given you. Now see, usually you have to multiply all the numbers, whichever way convenient you feel. But these are certain numbers when you can make your calculation easier using the properties 3 into 3, 2 into 5, 7 into 11. I've made groups. Then associative property 9 into 77 I put within groups. Then into 10, and this is the way. Okay. Now the next one is a similar sum. That's why I've given you here number 6 from your textbook. See the traffic lights at 3 different crossroads. Okay, so you know what is a traffic light, isn't it? So the one traffic light will be here, one will be here, one will be here. So at 3 different positions. Now they change simultaneously. When all these 3 change together at one point, after every 48 seconds they change. Now here there's another traffic light that will change after every 72 seconds, and here there'll be another traffic light that will change after 108 seconds. Okay, now if they change simultaneously at 7 a.m., at 7 a.m. all the 3 had changed together. At what time will they change simultaneously again? Now here I have not drawn 3 traffic lights, I'm just explaining you. Suppose you consider this to be one traffic light. Then this one, so this is the second traffic light here, this is the third traffic light here. Now if this is changing after every 48 seconds, this is changing after every 72 seconds, this is changing after 108 seconds. Now if they change at 7 a.m., at what time will they change again together? Isn't it? Simultaneously. So now it is like the same steps sum, isn't it? So you have to find the multiple, and what multiple you have to find? The common multiple, the common to all the 3. And if you have to find the next immediate time, it should be the lowest common multiple. So you find the LCM. I have not done the LCM for you. You will do the LCM complete steps. You will show the LCM of 48, 72, 108, any method. Now that LCM will be what? The lowest common multiple, that will be in seconds. That is, after that much second, they will again change simultaneously. So that is given in seconds. So you can write so much seconds after 7 a.m. they will change simultaneously. And you can divide by 60 also. The quotient will give you the minute, the remainder will give you the second. So you can also write so many minutes, so many seconds after 7 a.m. the lights will change. Is it clear, all of you? So I've just written the steps here. You can go through. Next is what? To determine the smallest 3-digit number, which is exactly divisible by 6, 8, and 12. So arrange it in this manner. You have to find a 3-digit number, smallest 3-digit number, which is divisible by 12 also, by 8 also, by 6 also. So from here, what do you see? That all this, if this is x, they should be the same number, isn't it? And they should be divisible by 12 also, 8 also, 6 also. That means what? X must be a multiple of 6, 8, and 12. So also that means what? X is a common multiple of 6, 8, and 12. So when you have to find the common multiple, what do? You have to find their multiples and then circle the common multiples. But here, let us first find out the lowest common multiple. I have not done the LCM for you. You are going to do the LCM here of 6, 8 and 12. LCM is 24. Now they don't want the LCM here actually. They also want the smallest 3-digit number. That means LCM is 24. That is the LCM. 24 is divisible by 6 also, by 8 also, by 12 also. But they want the smallest 3-digit number here. So remember, I had told you the next common multiple, once you know the LCM, you can find the next common multiple by multiplying by 2. The next will be multiplying. This is the third common multiple. Then you find the fourth common multiple. Then you find the fifth common multiple. So here you are getting a 3-digit number. So this is the smallest number, not LCM. This is the smallest common multiple, which will be divisible by 6 also, then by 8 also, by 12 also. Okay. This is another way, like suppose 100 is the smallest 3-digit number. Then you divide by 24, 4s are 96. Now 5s will give you the next first least 3-digit number, which will be divisible by 6, 8 and 12, isn't it? So you can stop here, you can do this method also, because you want a 3-digit number and the smallest 3-digit number. And also it must be the common multiple of 6, 8 and 12. So you find the LCM and accordingly you find the tables, the next common multiples, isn't it? And when you get the smallest 3-digit number, you get that. Now this is also similar to determine the greatest 3-digit number. But here now we need the greatest 3-digit number exactly divisible by 8, 10 and 12. So what do? We find the LCM of 8, 10 and 12. So do it yourself, the LCM. Now how will you find out the greatest 3-digit number? Okay. Last time we found the smallest 3-digit number. Now we have to find the greatest. Now you know LCM is 120. Just check, do it and by yourself and check. Now you find the next common multiple, then by 3, you keep on doing it. So now you get what? This is the 3-digit number, maximum common multiple, and then next is, this is a 4-digit common multiple. Now you need the greatest 3-digit common multiple, isn't it? So this is 960. It is a common multiple of the 3 numbers. Is it clear, all of you? Now this is another way like the previous one, whichever you find it convenient. Now the next one is the number, question number 8, the least number. Now this is also very similar to the previous sums. You have to find the least number, that is when divided by 6, 15 and 18 will leave remainder 5. This is another condition. See, you have to find the number which when divided by 18, 15 and 6 will leave remainder 5. Now first of all, this x will be a multiple of all the 3. So find the LCM. Instead of finding any common multiple, the LCM is the best method. You find the lowest common multiple. So that will be divided by 6 also, 15 also, 18 also, isn't it? But in each case, there is a remainder of 5. So if I add 5 to that multiple, now suppose here it is 12 I get. Now here of course the answer will not be 12, LCM will be different. I'm just telling you, suppose I get here 12 and 12 plus 5, 17 I get. So when I divide by 12 by 6, I will get remainder 5. So in this case, when I get the LCM and I add a 5 to it, so whenever I divide by all these numbers, that LCM, I will get a 5 as a remainder. So your answer is LCM plus 5. Okay. Now this sums, highlighted ones, you do in your classwork copy. Children, it's very important that all these are very important concept building questions. So please do it. So this is just the derivation from there. HCM into LCM is product of 2 numbers. That means if A and B are 2 numbers, And if you find HCF and LCM, you will observe that HCF into LCM is equal to A into B. So from here, if any one of them is not given and the other three are given, we can find out using this formula, okay? So this you just go through, and children, please, at the end of each lesson, there is a page where what have we discussed is given. That is very important. Go through each and every line. And next, in classwork copy, you also write this example to prove that HCF into LCM is equal to product of two numbers. Now let 6 and 8 be two numbers where A is 6, B is 8. Okay. So, and you find HCF and LCM. So when you multiply HCF into LCM, you get 24. 24 to this HCF is 2, LCM is 24. When you multiply, you get 48. Also 6 into 8 is 48. So if you take like this, any two numbers, find the HCF and LCM, you will find that this property holds true. HCF into LCM is equal to product of two numbers. Okay. So I hope that's clear to you. Till then, be safe. Goodbye.